Hi kids. In this video, what we're going to do is I'm going to go over finding area with KNEX shapes. It gets a kind of crazy when you're trying to measure and find area for shapes in KNEX because the accuracy or the degree to which you are measuring greatly influences the area. And you have to use a little logical deductive reasoning to come up with the correct answer, especially when it's a multiple choice question, okay? So anyways, first thing I want to talk about is if you have a rectangle, a shape like this made out of KNEX, and I ask you to find the area, you'd know that you'd want to use the formula of area equals the length times the width, okay? Length times width, all right? So basically, we just have to know the length and the width. However, measuring them can be a little bit crazy, okay? So like if we put our ruler here and we measure, we could measure to the outside of the rod. And when we do that, and I'm going to zoom down there so you can see the measurement there. When we do that, we get a measurement of about 21.5 centimeters, okay? So we could assume that that is 21.5 centimeters, okay? Then we could do the width, and when we do the width, if we measure from the outside edge of the rod to the outside edge of this rod, you'll see that we have a width of 8 centimeters, okay? So what we're working with is 21 5/10 and 8. Now, sometimes what we do, we will take and we will make marks like at each vertex or vertice, and then what we get to do is we get to draw the actual shape itself, okay? So, and then what we do is we find the area using what we have drawn, okay? And so this is one method of doing it. And when you do it like that, okay, you end up with the actual rectangle. Now, when I measure this to the nearest centimeter, what you'll notice, okay, is that if I bring the camera down, you'll notice that it actually, when it looks like it's closer to just plain old 21. So you could be thinking, okay, instead of using 20 5/10, I'm just going to use 21. And sometimes you might measure and you might say, okay, now that I've drawn this and I measure it, that's going to be, oh, well, geez, that looks closer to 7 5/10. Okay, so you might work with 7 5/10, okay? So for this actual shape right here, you could be working with a variety of different measurements depending on who's measuring it, okay? So watch what happens then when we find the area, okay? So for the first one, I'm simply going to take 21 5/10 times 8. And watch the area we get. We get an area of 172 square centimeters, which is right because we multiplied the length times the width. Now we're going to use the measurements that somebody else might have taken, which are slightly smaller, okay? So we're going to take 21 times 7 5/10. And this time our area comes out at 157 5/10 centimeters, okay? So there's quite a difference there, isn't there? Okay, and that has to do with the fact that this measurement and this measurement are a whole 1/10 of a centimeter bigger, both length and width. So if you had a multiple choice question and they wanted you to give the area of this, you might not even see either one of those. You might see something more like this. as a choice, okay? And so at this point, you kind of have to ask yourself, well, what is the best and most accurate measurement, okay? And what are they looking for? And this is just, this whole setup, this whole confusing situation really is a part of real life measurement, okay? In the real world, measurements can come at you in many different ways, and people try to have a standardized way of measuring things, but sometimes your standardized method isn't the same standardized method that somebody else is using. So measurements get a little wonky. So this is where you have to kind of use your ability to make sense of what it is that's being measured and how you think is most appropriate to measure it, okay? Let me show you another example of that, okay? Let's work with a right triangle, okay? And what we know about a right triangle is if you want to find the area of a right triangle, you could find that you have this formula, base times height divided by 2. They might ask you to use this formula, 1/2 the base times the height. Or they might say use this formula, base times height divided by 2. There are 3 ways that we sometimes ask you to find the area of a right triangle or a triangle, and it comes in different formulas. All 3 formulas are going to give you the same result. It just kind of depends on the situation and who's presenting it or how they presented it to you. But they all work, okay, mathematically. And so anyways, let's take a look at this triangle and see if we get the same area doing things differently, okay? So when I measure this triangle, okay, now remember, we only need the base and the height. We don't have to worry about this distance. That, if we needed this distance, we'd probably be looking for the perimeter. But we're talking about area, so we just need the base and the height, okay? So anyways, when I put my ruler down here, I see that, oh, okay, well, if I measure from the outside edge of that to the outside edge of the circle, okay, and I'm going to bring it down here, okay, give you an idea of what we're looking at, okay. When I look at this, I can say, okay, there's the measurement, and it looks like it's from outside to outside 11.5 centimeters, okay. So I'm going to say 11.5. Well, then, obviously, if this side is congruent with the other side, if the base is congruent with that, we could measure that and assume that that also is going to be 11.5 of a centimeter. And sure enough, it comes out at about 11.5 of a centimeter. So I'm going to mark this as 11.5 of a centimeter. So, but let's pretend that somebody decides they're going to use the inside of the circle method, okay? Inside of the circle method. And what they do is they draw the right triangle from vertex to vertex. Don't forget the hypotenuse. From there to there. I keep disappearing off my camera, don't I? Okay, so now we can take and we can do a little bit of measuring, okay? And, look at this. This is going to make a big difference, isn't it? If I measure from here to here, now I have 10.5 of a centimeter, which is really crazy because that's a whole centimeter smaller. I would assume that if I do the same thing on the height, yeah, that looks like, oh, let me adjust it. Yeah, that looks like I want to go with 10.5 also, okay? So now if I apply my formula, okay, if I apply my formula and I'm going to multiply the base times the height. Let's start with this first area, okay? So if I multiply 11 and 5/10 times 11 and 5/10, I get 132. I get 132 and 25 hundredths. And then I want to, okay, I did the base times the height. I'm going to divide it by 2, divide by 2. And so my area for this triangle is, it's giving me 66 and 125 thousandths. Well, for this practical purposes, I'm just going to round that to 66. I'm going to round that to 66 square centimeters. Not forget to put my little 2 up there. Okay? So now let's see how this changes when I use the 10.5. Okay? So I'm going to do 10 and 5/10 times 10 and 5/10. And wow! Okay, so now I have my 110 and 25 hundredths of a centimeter, which I'm going to divide by 2. And that comes out at 55 square centimeters approximately. So you can see where there is going to be a pretty big discrepancy depending on how you measure, okay? That's a part of real-world mathematics and real-world measurement. I've been a construction worker since when I was almost your age, and that's always something that you've got to deal with, and you've got to kind of establish with the people you're working with, how do I measure this? Now, I typically say, you know, in a situation where you just have a kind of a two-dimensional shape, I'll say measure from circle, circle to circle, okay, from circle to circle to circle. If it is a situation such as this, I oftentimes say, yeah, measure from the inside point to inside point. You can also measure outside to outside, all right? Now, it does get a little tricky when you have a compound shape such as this one, okay? When you have something like this, I can't even fit it on the screen, coming your way, now all of a sudden you have to think, okay, I'm going to find this point, this point, this point, this point, and this point, okay? And then I can imagine that this is decomposed into a rectangle and another rectangle, okay? So then what you can do is you can draw that shape and decompose it, okay? And come up with your area like so. You can still measure it and do it the way you originally, you can still measure and just take the measurements right off of this. That's up to you. This is just a little bit easier because then you can decompose the shape and you can turn it into two easier to work with shapes, okay? And this is what we would have, okay? So now all you'd have to do is find the length and the width of this one, and then the length and width of this one, and take those two and add them together, okay? And then you would get your area for the whole total thing. Likewise, you'll find that that would apply to a shape like this, okay? So a shape like this, you are looking at decomposing it into